All right, you ready for this? I don't think you're ready for this. Let's do some math. We're going to find the equations of the horizontal tangents to this snazzy equation here. So, what are horizontal tangents? Well, you know what this graph looks like. Well, kind of. It's a cubic function, so it's going to go like that. Now, tangents, remember, are lines that touch the graph but don't actually cross it. That doesn't actually touch it. Sorry, my stylus isn't doing so good there. So those are tangents, but those are not horizontal tangents, right? We want horizontal tangents, which are lines that actually are horizontal. So a horizontal tangent would be something like this one right here, or that one right there. In fact, I see two horizontal tangents. Now, tangent, yeah, it touches it there, sorry. But that's the unsnazziness of my fatty stylus here. So, deal with it. You got the idea. We're looking for two horizontal tangents. Now, when it asks for the equations, what does a horizontal equation look like? Well, the x value on this line can change because I'm moving from the right to left. But if it's horizontal, then the y value is always the same. So it should just be y equals something. Okay? And this one should also be y equals something. Now, a lot of times they'll actually say, well, write it in the equation such that f of x equals k or something like that. All that means is that it's a horizontal line because y is equal to a constant. And that's a horizontal line. You'll see that. Okay, so let's go ahead and see if we can work it out. Of course, if I want a tangent, then I'm going to need to find the derivative. That kind of reminds me of those books. You ever read if you give a mouse a cookie? If you give a mouse a cookie, he's probably going to ask for some milk, and then it goes on and on and on until he gets more cookies. This is kind of like that. If you want to find a tangent, you got to find the derivative. If you want to find the derivative, you got to follow the derivative rules. If you want to follow the derivative rules, you better learn them from Mr. Bywater. All right, so we bring the 3 in front, that's 6x squared. 2 in front, that makes it 6x, and then minus 12. This looks somewhat familiar. I think I've done this one before, or used this equation anyway. But anyway, there we go. We got the derivative. We're going to go ahead and factor it because I'm trying to solve. If I want the horizontal tangent, then I want the derivative to be equal to 0. Very good, Mr. Bywater. So I'm going to go ahead and make the derivative 0. And we solve. I'm going to divide everything by x, which is going to give me x squared plus x minus 2. And then I'm going to factor it. So then I'm going to have x plus 2, x minus 1. Set each of those pieces equal to 0. And I end up with x equals 2. Negative 2. And x equals 1. So those are the x values where it will occur. Now, that doesn't answer the question. Remember, because a derivative, if I want it to be a horizontal tangent, then it has to be y equals. So I have the x value, so the x value here at this is going to be negative 2, and the x value here is going to be positive 1. Now, how do I get the y value for my horizontal tangent? Well, I'm going to go ahead and put that into my equation. So if I put negative 2 into my equation, then I will get some number. Now, I'm going to show you how to do synthetic substitution because I don't want to plug this in. One way to do this would be to put the negative 2 in and work it out. But synthetic substitution, you can take the negative 2, and we're going to put the coefficients. So the coefficient of the x cubed was 2, coefficient of the x squared was 3, coefficient of the x is negative 12, and coefficient of, the constant is 1. So I bring down the 2, negative 2 times 2 is negative 4, 3 minus 4 is negative 1. Negative 2 times negative 1 is positive 2, negative 12 plus 2 is negative 10, and then negative 2 times negative 10 would be 20. Add those together, I get 21. So if I put negative 2 into this function, I get 21. You don't believe me? Try it out. All right, now you don't have to do this synthetic substitution thing. You can go ahead and just put the negative 2 in, you can put the 1 in, but I'm going to go ahead and do it because I want to show it to you anyway so you get an idea of how it works. You should have seen this back in Algebra 2, but just in case you didn't, we're doing it now. So again, I put the coefficients, 2, 3, negative 12, 1. So if I put the 1 in, remember I'm substituting these into the original equation. I've got to put it into the original equation if I want to know the value of the points there. Okay, so bring down the 2. 1 times 2 is 2. 3 plus 2 is 5. 1 times 5 is 5. Negative 12 plus 5 is negative 7. 1 times negative 7 is negative 7. 1 plus negative 7 is, or 1 minus 7 is negative 6. Okay, so I get negative 2, comma, 21, and I get 1, comma, negative 6. Now, those are the 2 points, and then the horizontal tangents would therefore be, for the negative 2, y equals 21, and for the 1, it would be y equals negative 6. And those are the 2 equations for the horizontal tangents to the graph given. You know what? That was pretty dang fast. So what we're going to do is we're just going to pause it, and you can watch the next video. How about that?